Before we explore the evidence of evolution, there are several terms that need clarification to aid our better understanding of how science must be correctly perceived and practiced. We continually hear of the theory of evolution. However, many of those who have not studied science often have an incorrect perception of this word. In the common vernacular, the word theory is used offhandedly to mean an idea or belief that guides behavior, such as, I have a theory on how to play the stock market. The word can also be used in reference to a speculation about something not entirely supported by concrete evidence, such as in the term conspiracy theory. To the contrary, a theory in the scientific, mathematical, or musical sense carries a much different connotation. The concept of music theory attempts to define and analyze the elements or parameters of music, that is, melody, rhythm, structure, texture, form, and harmony. In much the same way, scientific theories such as Newton's theory of gravitation or Darwin's theory of evolution account for many facts and attempt to explain a great variety of phenomena. Such a unifying theory does not become widely accepted in science unless its predictions stand up to thorough and continual testing by experimentation and observation. Therefore, a scientist cannot simply make up his or her results, for one's peers must be able to follow identical methods, whether through experimentation, mathematical calculations, or measuring data, and obtain similar conclusions. Even then, good scientists do not allow theories to become dogma, or absolute truth. This means, although a theory is a comprehensive explanation of a given set of data, which has been repeatedly confirmed by observation and experimentation, and has gained general acceptance within the scientific community, it cannot be decisively proven. An important distinction to make clear is how science regulates proof and disproof of theories and hypotheses. In general, scientists hold the belief that a hypothesis cannot be proven, only disproven. This is especially so in historical sciences like paleontology, where a time machine would be the only true way to prove a hypothesis. Even in the study of evolution, biologists question whether natural selection is the sole mechanism responsible for the evolutionary history observed in the fossil record. Therefore, no theory in science can be absolutely proven as truth. Another important distinction to make clear is the difference between fact and opinion. A fact, in a scientific context, is a generally accepted reality, but still open to scientific inquiry, as opposed to an absolute truth, which is not, and hence, not part of science. In science, a fact generally refers to repeatable observations under controlled conditions, such as, it is a fact that the speed of light is constant in a vacuum. This aspect of science will be the same a century from now, unless more precise measurements show otherwise. Opinions are neither fact nor theory, and are not officially the domain of science. However, scientists do have opinions, as they are only human, and opinions often help guide research. But science cannot directly address such issues as whether God exists or if people are good or bad. Hypotheses and theories are generally based on objective inferences, unlike opinions which are based on subjective influences. For example, I am a humorous person is certainly an opinion, whereas if I drop this glass it will break could be best described as a hypothesis, while the Earth orbits the Sun, or bacteria can cause disease, or evolution occurs over time are considered both facts and theories. Because science can never prove a theory to be true, truth has no place in the realm of science. What is meant by truth is what really is going on. Truth has to do with the ultimate causes, which are elusive and beyond the realm of science. Science deals with theories, usually mathematical, which predict outcomes of experiments. For example, if we drop a rock off a cliff, the law of gravity, combined with the theories of air resistance and other forces, can be used to calculate how long it will take to hit the ground, how fast it will go, and so on. But science does not answer the question of exactly what gravity is or why things fall. It just states given certain conditions, they will fall. In general, science answers questions like how, when, where, but never why in the ultimate sense. As an example of the interplay between the concepts of observations, hypotheses, and truth, let us consider a courtroom. The observation is that a man was seen shooting a gun and the person hit by the bullet died. A hypothesis might be it was cold-blooded murder, although the truth could be that it was in self-defense. Truth tends to be invisible and hidden, such as someone's motives, whereas observations are usually visible. Courts are very interested in truth, where the motive or the ultimate cause behind an action is given considerable weight. The distinction between first-degree and second-degree murder is based on intent. Motives are not observable within science and are hence beyond the realm of science. Scientific theories are supported by facts, where the theory is a generally accepted explanation of a scientific concept. As an example, let's explore the theory of electromagnetism. It began as a hypothesis or an educated guess. Experimentation led to failures, successes, and breakthroughs. As a concept developed, a wider understanding was born and the theory became a field of study. The first breakthrough was electromagnetic current, then the electron magnet, followed by magnetic propulsion, a motor, electric engines, circuits, circuit boards, conductors, superconductors, and so on. Each level of technology is built upon previous knowledge. Through this process, many facts are discovered and support the theory as it becomes more refined and comprehensive. The farther technology advances, the more precision is required. For example, calculating a magnetic field for a motor does not require the same level of precision as an MRI used in hospitals. Therefore, a theory is never complete or ever proven. It is continually built upon and expanded as new heights of understanding are achieved. Evidence shows evolution is both fact and theory. However, to be more precise in our understanding, we must examine what facet of evolution is fact and what is theory. Biologists consider the existence of biological evolution to be a fact. Evolution can be demonstrated, and the historical evidence for its occurrence in the past is overwhelming. However, biologists readily admit they are not 100% certain of the exact mechanism by which evolution occurs. Therefore, the mechanism of natural selection, by which evolution occurs, is continually being investigated and built upon, just as the theory of electromagnetism is built upon the natural laws of the physical universe. It is important to understand that facts are simply the world's data, and theories are the structures of ideas that explain and interpret the facts. Facts do not go away when scientists debate rival theories to explain them. Einstein's theory of gravitation replaced Newton's theory, but gravity did not stop working pending the outcome. Therefore, it is a fact that modern-day humans evolved from ape-like ancestors, whether we did so by Darwin's proposed mechanism of natural selection or by some other yet to be discovered.